Hello friends, we are going to discuss beta function today. So earlier we have seen revision of gamma function. Now beta function, it is defined as the integral of this particular form 0 to 1 x raised to m minus 1, 1 minus x raised to n minus 1 dx, and it is denoted by beta of mn, where m and n are the integers which are greater than 0. So this integral, it is used in to evaluate certain double integrals also. It is written in the form 0 to 1 by changing the variables m minus 1, 1 minus t bracket raised to n minus 1 dt, or in terms of y, any variable, because a variable does not change the value of this integral. Variable is immaterial. Now we discuss certain properties. So I have written few properties here. The first property, beta mn is equal to beta nm. Commutative, if you interchange m and n, it does not change the value of beta function. Second, it is relation between beta and gamma function. Beta mn is equal to gamma n upon gamma m plus n. Now where it is used exactly, suppose you need to find value of beta 2 3, then it is something like this: beta gamma 2, because m is 2 n is 3, gamma 3 divided by gamma 2 plus 3, it is 5, gamma 2 is 1 factorial, gamma 3 is 2 factorial, divided by gamma 5 is 4 factorial, as we have seen earlier. So 2 divided by 4 factorial is 24, so it is 1 by 12. So this is the way you can find out the other values also. And there is one more form of the beta function, that is 0 to infinity form. Most of the integrals are reduced to this particular form, 0 to infinity. You can write t raised to m minus 1, 1 plus t bracket raised to m plus n also into dt, or in terms of y, any variable. So variable does not matter here, it is immaterial. You can take any variable, you are getting the same value. Similarly, there is one more property or the formula which is derived from this. So it is 0 to pi by 2 sin raised to p cos raised to q d theta. It is half beta of p plus 1 divided by 2 q plus 1 divided by 2. So mostly if you need to find value of the integrals like 0 to root of sin theta, it is not possible by traditional integrals. So we can just find out this value by using this kind of the integral. Similarly, root of tan theta, root of cot theta with the limits 0 to pi by 2. So this is the use of this particular property. Then next is gamma p, gamma 1 minus p. It is pi upon sin p pi, where p in between 0 and 1. If you take some values like say gamma 1 by 4, gamma 3 by 4, then you can write down, find out value of this by using this integral. It is pi upon sin p. So I take p as 1 by 4. So it is sine of pi by 4. So this is equal to pi upon pi by sine pi by 4. It is root 2. So something you can just see this. So this is 1 by 4 p, and 1 minus p is 3 by 4. So you can just find out this value. Now similarly, the next property is actually, this is duplication formula. This is called duplication, same application, duplication formula of beta function. And so this is all about this summary of beta function. Now we shall see some applications, some illustrated examples on beta function. So how to reduce certain integrals to beta integrals and how to find out their values, that we shall see here. So the first illustrated example here. So the first example 1. Evaluate the integral 0 to 1 x x cube into 1 minus root x bracket raised to 5 into dx. So if you observe this integral, so it is reducible to beta. Now if you observe, you know the basic integral of beta function 0 to 1 x raised to m minus 1 or t raised to m minus 1 1 minus t bracket raised to n minus 1 dt. This is beta mn actually. So I would like to reduce this in this form. As I said earlier in terms of gamma, how to reduce this integral to this particular form. So it's very clear from here that the suitable substitution to be taken. So you should have always 1 minus t here. So with respect to t, so 1 minus t. So I use the substitution. So it's very clear that I'm using substitution root x is equal to t in order to reduce in this particular form. So x is equal to t square if you square on both sides, and dx is if you differentiate, it is 2 times t dt if you take the differentials, and limits would be same if you observe from this expression. For x is equal to 0, t is equal to 0. For x is equal to 1 if you put here, then t is equal to 1. So limits would be same there. So this integral will get transformed to this particular form 0 to 1 x, it is t square bracket cube 1 minus t bracket raised to 5, and dx is 2 times t dt. So we just simplify this and try to reduce this integral to beta integral and get the value 0 to 1. So t raised to 6 here, t raised to 6. This is, I take this 2 outside and here t and 1 minus t bracket raised to 5 into dt. So this is equal to 2 times integral 0 to 1 t raised to 7 1 minus t bracket raised to 5 into dt. I just compare with this integral and just get the values of m and n 0 to 1. So the first I will write down this as t raised to 8 minus 1, because 7 m minus 1 I will write down 1 minus t bracket raised to 5. So I will write down this as 6 minus 1. So m is 8, n is 6. So the value of this integral in terms of beta, it is 8, 6. So this is value. You can just find out, simplify this by using relation between beta and gamma function as gamma 8, gamma 6 upon gamma 8 plus 6 means 14. So likewise also you can just work out that, but it is just sufficient the answer up to this particular form. So we go for the next example. The next example on beta function. Second problem. Second problem is show that the integral 0 to infinity x raised to m minus 1 divided by a plus bx bracket raised to m plus n dx. This is equal to 1 upon a raised to n b raised to m beta of mn. So see this, show that this problem. So if you observe this problem, LHS is equal to RHS. So you have to see the appropriate form. Let I is equal to the integral 0 to infinity x raised to m minus 1 divided by a plus bx bracket raised to m plus n dx. Now if you just observe this integral, so this is not the basic form of the beta function. So you have to, we have this particular form t raised to m minus 1 divided by 1 plus t bracket raised to m plus n dt, this is equal to beta mn. So you have to reduce this particular form. So how you are going to reduce this? So it's very clear, you need to have 1 plus t there. So a plus b means I have to use the substitution bx is equal to at, so that a can be taken outside, you are getting 1 plus t over there. So I use the substitution, put bx is equal to at, so b and a are constants, so x is equal to a upon b into t. So we take the differentials, therefore dx is equal to a upon b into dt. And limits, if you observe, for x is equal to 0, for x is equal to 0, if you observe here, t is equal to 0, for x is equal to infinity, t is equal to infinity. So these are the new limits there, t from 0 to infinity. Now I will just get transform this integral to this particular form. So from this integral, from 1 will get transformed to this integral 0 to infinity in terms of t. I just put for x, from here it is a upon b bracket raised to m minus 1 divided by a plus at, bx is equal to at bracket raised to m plus n, and dx is a upon b into dt. So we simplify this, take all constants outside there. So I just take this outside, x actually, this is t. So I just take all the constants outside. So a upon b I take it outside, bracket raised to m minus 1. From here a upon b raised to 1 and divided by a raised to m plus n from here, and inside the integral sign I am getting t raised to m minus 1 divided by 1 plus t bracket raised to m plus n into dt. I simplify this further. So this I am getting a upon b bracket raised to m minus 1 plus 1, it is 0 raised to m. I am getting a raised to m plus n, and the integral 0 to, or I just write down this as, so this integral, if you compare, this is beta of mn, and further we simplify this, a raised to m gets cancelled there. So a raised to m, if you simplify, gets cancelled from here, and you are getting 1 upon a raised to n b raised to m over here, so into beta mn, and that is your RHS solution. So this is the way you can just simplify, reduce certain integrals to beta integral by choosing the appropriate form of the beta function, related 0 to 1 or 0 to infinity, and get the value. We shall see some more examples here. So problem number 3, show that the integral 0 to infinity dx upon 1 plus x raised to 4, this is equal to pi upon 2 root 2. Now this is again the same technique we are using. So this integral can be reduced by the substitution solution. Let I is equal to the integral, this is equal to 0 to infinity, LHS integral I will consider, x raised to 4. So as I said right now, the substitution beta mn is equal to 0 to infinity t raised to m minus 1 divided by 1 plus t bracket raised to m plus n dt. So in this form, because limits as usual 0 to infinity and so on. So I put the substitution, it's very clear from here, x raised to 4 is equal to t. So put, because 1 plus t raised to m plus n, so put x raised to 4 is equal to t. So x is naturally raising its power by 1 by 4. So x is t raised to 1 by 4. I take the differentials, dx is equal to, I take the derivatives, 1 by 4 t raised to 1 by 4 minus 1 into dt. So it would be something 1 by 4 t raised to minus 3 by 4 into dt, and limits would be same again. So if you put t is equal to 0, if you put t is equal to 0, x is equal to 0, I'm sorry, t is equal to 0 for x is equal to infinity, t is equal to infinity, the new limits would be same there. So what happens, see here, then this integral will get transformed, therefore I is equal to the integral with new limits 0 to infinity dx. I put it from here, it is 1 by 4 t raised to minus 3 by 4 into dt divided by 1 plus t. So you can just simplify this and get the particular form. This is equal to 1 by 4 0 to infinity t raised to minus 3 by 4 into dt divided by 1 plus t bracket raised to 1. So you can just reduce, see the form 0 to infinity t raised to m minus 1 divided by 1 plus t bracket raised to m plus n dt, this is equal to beta mn. So if you observe this, so m minus 1 is equal to minus 3 by 4, so m is equal to minus 3 by 4 plus 1, so naturally it is 1 by 4. So you can write down this as m is 1 by 4, so naturally m plus n 1 by 4, then n naturally it is 3 by 4. So you are getting this as 1 by 4, this integral I can write down this as 0 to infinity t raised to 1 by 4 minus 1 divided by 1 plus t bracket raised to 1 by 4 plus 3 by 4, something like this dt, and this would be 1 by 4 beta of 1 by 4 3 by 4. So this is in terms of beta. Now I use relation between beta and gamma. It is gamma 1 by 4 gamma 3 by 4 gamma n upon gamma m plus n divided by gamma 1 by 4 plus 3 by 4, it is 1 actually. So you are getting this in the form 1 by 4, and this is pi upon root 2 just now, right now we have seen, divided by this value gamma 1. So you are getting this as pi upon, so this is the form you are getting, gamma 1 gamma 3 by 4 pi root 2, I'm sorry, this value is pi root 2, so this pi root 2 and this value is 1, so pi root 2 upon 4 into 1, so this is pi upon 2 root 2, and that's what the RHS is required. So this is the way you can just evaluate such type of the integrals, and we go for the next illustrated example on this. Next example is evaluate this value, evaluate the integral 0 to infinity x raised to 6 1 minus x raised to 8 1 minus x raised to 6 divided by 1 plus x bracket raised to 24 into dx. So you have to find the value of this integral. So it's very clear from here. Again, I just guess the integral 0 to infinity t raised to or x raised to m minus 1 divided by 1 plus x bracket raised to m plus n dx. This is equal to beta mn. So what you are doing here, let I is equal to this integral 0 to infinity x raised to 8 1 minus x raised to 6 divided by 1 plus x bracket raised to 24 into dx. Now I just simplify this 0 to infinity. x raised to 8 minus x raised to 14 divided by 1 plus x bracket raised to 24 into dx. I just split up this integral into two integrals as 0 to infinity x raised to 8 divided by 1 plus x bracket raised to 24 into dx minus 0 to infinity x raised to 14 divided by 1 plus x raised to 24 into dx. So I just apply this integral over here, and here m minus 1. So I will write down this as 9 minus 1. Here I will write down this as 15 minus 1, m minus 1. And if it is 9, then naturally here 9 plus 15, here 15, so it is 15 plus 9 I can split, and accordingly I use this formula and get this as beta of 9 15 minus, here if you observe, beta of 15 9. So by commutative property of beta function, so this vanishing, so this is 0, this is value of this particular integral. So likewise you can use beta integral. The rest of the forms, many more forms, you can just use it there. Next is there is one integral a to b x minus a bracket special integral x raised to m b minus x bracket raised to n dx. If this kind of the integral occurs, then all the time we use the substitution x minus a is equal to b minus a into t. So this is important thing. So we use this substitution for such type of the integrals and reduce it in the form 0 to 1 t raised to m minus 1 1 minus t bracket raised to n. So let us see one example on this. One example. So if you see this problem, evaluate 3 to 7 x minus 3 bracket raised to 1 by 4 7 minus x bracket raised to 1 by 4 into dx. Suppose I would like to find value of this integral. Then this is of this particular form. So naturally a is 3, if you observe, b is 7, so the substitution, as I said here, put x minus a means x minus 3 is equal to b minus a means 7 minus 3 into t. So this is x minus 3 is equal to, this is 4 into t. Therefore x is equal to, taking this minus 3 on this side, 4t plus 3. So dx is 4 times dt you are getting. Okay. Now if you think of limits, then limits automatically follows here. If you take x is equal to 3, for x is equal to 3 minus 3 0, for x is equal to 3 t is equal to 0, for x is equal to 7, then 4 gets cancelled, t is equal to 1. So these are the limits of basic integral of beta function. So I just go for this. Then this integral from 1 I get it transform from 1. So how it is transformed? See, I is equal to the integral with new limits 0 to 1 in terms of t, x minus 3 would be, from here it is 4 times t bracket raised to 1 by 4 and 7 minus x, I just 7 minus x is, x I put it 40 plus 3 and bracket raised to 1 by 4 and dx I take it from here, it is 4 times dt, and we simplify this is equal to, I just take all the constants outside, so or I just simplify further, 4 raised to 1 by 4 t raised to 1 by 4 inside the bracket, 7 minus 3 4 minus 4t bracket raised to 1 by 4 into dt. we just take this 4 raised to this outside, and this outside. So it is 4 raised to 1 by 4, 4 raised to 1 by 4 from here, 4 raised to 1 by 4 and 4. 4 multiplied by integral 0 to 1 t raised to 1 by 4 1 minus t bracket raised to 1 by 4 into dt. So this is comparable with the beta function. Beta, you know, beta mn basic integral, it is 0 to 1 t raised to m minus 1 1 minus t bracket raised to 1 by bracket raised to n minus 1 dt. So you have to see the values of m minus 1. So 1 by 4, m minus 1 is 1 by 4, 1 by 4 m minus 1. So m is equal to 5 by 4. So I can write down this as 5 by 4 minus 1 and this also 5 by 4 minus 1. So this is equal to 4 raised to 1 by 4, 4 raised to 1 by 4 plus 1 by 4, 1 by 2 and multiplied by 4, beta of 5 by 4, 5 by 4. So this is, so if you simplify this, 8 times beta of 5 by 4, 5 by 4. So this is the way you can just evaluate such type of the integrals using, so this is special important integrals there. So you have to identify the values of a and b and then take the suitable substitution using this b minus a and then transform in terms of this particular form with limits 0 to 1, get it transformed in terms of t and express as a beta function. So this is the way you can use beta function over here. Now there are more examples here on beta function. Show that 0 to 1, 0 to 1, 0 to 1, 1 minus x raised to 1 by n bracket raised to m into dx. This is equal to m factorial n factorial upon m plus n factorial. Now if you observe this integral 0 to 1, 1 minus x raised to. Now just for instance, if you observe limits 0 to 1, so 0 to 1 t raised to m minus 1, 1 minus t raised to n minus 1 dt, this is equal to beta mn. So we are using this integral here. So what could be the substitution? It's very clear. The substitution, it is taken as this. Very clear. So I just solution, let I is equal to the integral on the left hand side 0 to 1, 1 minus x raised to 1 by n bracket raised to m into dx. So as I said right now, put x raised to 1 by n is equal to t in order to have 1 minus t. So x is equal to t raised to n. Therefore dx is equal to n into t raised to n minus 1 dt and limits would be for x is equal to 0, t is equal to 0, x is equal to 1, t is equal to 1. So get it transformed. So this integral will get transformed to this particular form 0 to 1, 1 minus t bracket raised to m dx. Dx is n into t raised to n minus 1 dt. I just take this n outside, 0 to 1, t raised to n minus 1, 1 minus t bracket raised to m into dt. So I just write down this as m plus 1 minus 1 in order to have this particular form here. So it is n. I write this as beta of n, m plus 1. So using this particular form. So by relation between beta and gamma function, n gamma m plus 1 divided by gamma